Hello everyone, welcome to Miss Lee's class. Today we're going to learn how to interpret graphs of linear functions. So today what we're going to learn is intercepts, how to use intercepts, x and y intercepts, rate of change, domain and range to describe the graph of a linear function. One question, this graph shows the height of a float plane above a lake as the plane descends to land. So a float plane starts descending at 1,000 meters, at a height of 1,000 meters, and the height is decreasing and until it gets on the land, on the ground. All right. So where does the graph intersect? The vertical axis. Here, it intersects at 1,000, the height of 1,000. What does this point represent? 1,000 meters, and this represent height, the height of the plane when it started descending. Okay? So this is the vertical intersect. What does the graph intersect the horizontal intersect? Here's the horizontal intersection. So what does this point represent? What does this mean, everyone? So it's 10 meters, 10 minutes. What does 10 minutes mean here? It is the total time of descending. Total time of descending, right? Okay, state the height of a float plane after 8 minutes using a function notation. Okay, after 8 minutes, this is the function notation. After 8 minutes, it is at a height of 200 meters. So 8, 200. So if we use the function notation, so we say f of the input is the time, f of 8 equals the output is 200. 8, 200. f of 8 equals 200. What is the rate of change for this graph? What does it represent? Okay, everyone, what is the rate of change? I briefly went over in chapter 5. So rate of change is basically change in x. So I want you to write it down. Rate of change is same as slope. Rate of change is change in vertical variable over change in horizontal variable. So it's usually change in y over change in x. But in this case, so we're using h for vertical variable, so change in h, and we're using t for horizontal, so change in t. Okay, change in h over change in t. So let's see how it actually changes. Okay, so look at this. So we are going to find 2 points. Let's just pick 2 points. I'm going to pick 800, 2, 800, and I'm going to pick 600, 4, 600. Okay, I'm going to pick those 2 points. Okay, from this point to this point, so we are going to look at the y value, h value first. Okay, so here 800 to 600 is going down. 800 to 600 is negative 200. And from 2 to 4, it's increasing, plus 2. So change in h is negative 200 and change in t is positive 2. So the fraction, we're going to have a fraction, negative 200 over 2, which is negative 100. So this is the rate of change. So every minute, it goes down 100 meters. So negative 100 meter per minute. So this is the rate of change. Okay? So rate of change, 100 meter, negative 100 meter per minute. So what does it represent? Descending 100 meter per minute. Okay? Alright, let's move on. Example 1. Each graph below shows the temperature over time for 2 locations. Okay, so temperature in location A and temperature in location B. Okay, let's look at A first. Okay, so here, if you look at this, do you think the graph is going up or going down? So it is actually going up. Is that right? So in this case, so before we actually calculate the rate of change, we can see that the rate of change is actually positive because the temperature is increasing. It's going up, okay? So just by looking at this, the temperature is increasing and the rate of change is positive. But what about this one? Is it increasing graph or decreasing graph? It's going down. Therefore, the rate of change is negative because the temperature is decreasing over time. All right? Okay, let's look at the first question. Find the horizontal intercept. What does it represent? So here, horizontal intercept 4 hour. So what does it represent? The temperature is, what is the temperature at 4 hour, after 4 hour? 0. So we say the temperature is 0 Celsius degree after 4 hours. Next, find the vertical intercept. What does it represent? Vertical intercept here, which is -5. Okay, what does it represent, everyone? -5 Celsius degree. It represents the initial temperature when you start measuring it. Okay, the initial temperature. And domain and range. So let's look at this. So domain is t values, small t value. So small t, the minimum t value, minimum time is 0, and it ends at 12 hour. So the domain t is t bar. T is greater than or equal to 0, less than or equal to 12. Okay? And the range. If you look at range, the minimum large t value is starting from -5. It goes to 10. Is that right? So 10 is the maximum large t value, -5 to 10. So we say large t bar, t is greater than or equal to -5 and less than or equal to 10. So this is the range. Okay, now we're going to find the rate of change. What does it represent? Rate of change. So to do that, we're going to find 2 points, which is, so it's already given 2 points. Okay, from here to here, when you move from this point to this point, time is increasing by 4, and the temperature is increasing by 5. So rate of change should be change in large t over change in small t. So large t, the change is 5, and the small t, the change is 4 hours. So this is the rate of change. If you calculate it, it is 1.25 Celsius degree per hour. So it goes up by 1.25 degree each hour. Okay? So you say it goes up by 1.25 degree each hour. Okay, next. So the horizontal intercept. So we're going to find the horizontal intercept, which is 5 hour. What does it represent? Same thing. After 5 hours, the temperature is 0. Find the vertical intercept, which is 10 Celsius degree. So this is also the initial temperature. And domain and range. The domain is from 0 to 10. So here we say T bar. T is greater than equal to 0 or less than equal to 10. And the range, the minimum value is -10, maximum is 10, from -10 to 10. Also you say T bar, large T bar, T is greater than -10, less than or equal to +10. Okay? Rate of change. So now we're going to use 2 points here. So when you move from this point to this point, the hour, the time is increasing and the temperature is dropping, right? So change in large T is this, change in small t is this. So we're going to find change in large T over change in small t. That will be -10 degree over 5 hour. And if you calculate it, that is 2 degree per hour. So we say the temperature goes down by 2 degree per hour. Example 2. A candle manufacturer found that their long-lasting candles melted according to the formula H of T equals -2T plus 12, where H is the height in centimeter after T hours. Okay, so use the table of the value to sketch the graph of the function and show the graph on the grid. So H of T is -2T plus 12. So we're going to starting from 0. If T is 0, what is H of T? That is -2 times 0 plus 12, and which is 12, right? Okay, 1. When H is 1, -2 times 1 plus 12. So -2 times 1 is -2 plus 12 is 10. H of 2. So -2 times 2 plus 12. So -2 times 2 is -4 plus 12 becomes 8. So 2, 8. So if you look at this, every time T is increased by 1, the height decreased by 2. So if T is 3, it becomes 6. Okay, so let's plot it. 0, 12, 1, 10, 2, 8, 3, 6. It keeps going on and on and on. And everyone, can you guys find a point in between 2 points? For example, the candle should have the height when it is 0.5 hours, right? So there should be a point in between 2 points. So therefore, we have to join the points. This is continuous data because the height is measurable, not countable, right? Okay, so determine the value of h of 5 and write in word the meaning of h of 5. Okay, h of 5. That means you plug 5 into h. Then negative 2 times 5 is 10. Negative 10 plus 12, that is positive 2. Meaning, after 5 hours, the height of the candle is 2 centimeter. All right? Find the both horizontal and vertical intercepts. Okay, vertical intercept 12, horizontal intercept 6. So what does that mean? What do the intercept represent? So horizontal intercept 6 hours. What does this mean, everyone? This means after 6 hours, the candle is completely melted here. Okay, vertical intercept, which is 12 centimeter. This is the initial height of the candle. Okay, how long will it take for the candle to burn down to a height of 7 centimeter? 7 centimeter. So h is 7 centimeter. And if you look at t value, that is 2.5. Okay? So if you use a graph, so you can either using the graph or using the formula. So using a graph, we know it's a 2.5, or if you use the formula is h of t equals negative 2t plus 12. The height is 7 centimeter. So we have to let h of t be 7. So 7 equals negative 2t plus 12. Minus 12. Then that becomes negative 5 equals negative 2t. Now you divide both sides by negative 2. Then becomes 2.5 equals t. So after 2.5 hours, the height of the candle becomes 7 centimeter. So 2.5 hours is the answer. Okay? Find the domain and range. Can the height of the candle becomes negative? No, it cannot be negative. It should be always positive. What's the initial height of the candle? 12 centimeter. So the range is 0, in between 0 to 12. And the domain. So we started measuring the height of the candle from 0 hour. It cannot be negative hours, right? 0 hour to 6. So domain is okay. So we're going to use the set notation T bar, H bar, h is in between 0 to 12. All right? Okay, what's the rate of change? Rate of change. To find the rate of change, we choose 2 points, 2 easy points. Any points can be chosen. So I'm going to choose those 2 points. Okay. If we move from this point to this point, the number of hour increased by 1 hour. And this is decreased by 2 centimeter. Okay? So change in H over change in T. So change in H is -2. T is 1 hour. So -2 centimeter per hour. So it's decreased by 2 centimeter each hour. Okay? Alright everyone, that is it for today. Now I want you to start doing your homework. Thanks for watching everyone. Bye!